relation between real depth, apparent depth and refractive index. When a ray of light passes from denser medium to rarer medium, the refracted ray bends away from the normal. Now look at the two media. An object O is placed in denser medium, and the person is looking from the rarer medium. The two media are separated by the surface which is x dashed. X dash is a plane surface which separate rarer medium from denser medium. The object O is placed at a depth h below the surface of separation in the denser medium. A ray of light passes normal to the surface of separation, goes without any deviation. No refraction takes place to the ray ON. Another ray which is falling obliquely, that is OM, which is falling at the surface of separation by making an angle I with the normal to the point of incidence. I is the angle of incidence. The ray refracts away from the normal, and R is the angle of refraction. Angle R is larger than angle I. For a person who observes from the rarer medium, the person feels that the position of object is at O dashed. So he is not seeing the actual position of the object. Instead, he sees the apparent position of the object. Now let us consider O dashed is at a depth h dashed below the surface of separation. The triangles ONM and O dashed NM are similar triangles. ONM and O dashed NM. These two triangles are similar triangles. So what is sin I? If this is the normal is parallel to another normal, and OM is the transversal. So if I is the angle of incidence, then angle MON is also I. Similarly, these two normals are parallel and MO dashed is the transversal. If R is the angle of refraction, corresponding angle is R, which is MO dashed N. Now from these two triangles, what is sin I? Sin I is equal to NM by OM. Let that be equation number 1. But these 2 points N and M are close by if I is very small. For small angle approximation, OM is approximately equal to ON since the distance between N and M is negligible. Similarly, O dashed M is approximately equal to O dashed N. So what about a sin R from triangle O dashed MN or O dashed NM? Sin R equal to NM divided by O dashed M. Since these 2 points are close by, sin R equal to NM divided by O dashed N. Let this be equation number 2. So we got sin I and sin R. Sin I by sin R equal to Nm by On divided by Nm by O dashed N. According to Snell's law, sin I by sin R equal to refractive index of rarer medium with respect to denser medium. The equation can be rewritten as refractive index of rarer medium with respect to denser medium is equal to Nm by On into O dashed N by Nm. Nm get cancelled out. So refractive index of rarer medium by refractive index of denser medium equal to O dashed N by On. And what is O dashed N? O dashed N is the apparent depth H dash. On is the real depth H. Substituting Nr by Nd equal to H dash by H. So what is the refractive index of denser medium by refractive index of rarer medium? That is H by H dash, which is equal to real depth by apparent depth.